what we know is 12% of sugar. Okay, very sweet. Let's add some water. So we have here grams. Percent of sugar. And grams of sugar. The second, talking about this terminology of object-oriented languages, we have 3 objects and 3 properties of these objects. Who understand up to this point everything? Raise your hand. Okay. Everybody, I ask you who, Maxim, you must raise hand. 2 seconds. You have rule of 2 seconds. Now, incorporate this table, this matrix with data. You know, this is 100 grams, write down 100 grams. How much water, they don't know, we don't know either. If you add in container, in a glass, you had 100, you added X, you have 100 plus X. So far, so good? Any questions? Who understand this step, raise your hand. Good. Now, incorporate this data. This is 12%, which is convert to decimals 0.12. I divide by 100. Nathan, what are you supposed to write over there? Can hear you. Try and participate. Try not to escape from here, okay? You're under personal control right now. Who will help you? Alexei KH. What is supposed to write over there?
0%.
Explain why. Why it's 0?
Because that water doesn't come with sugar.
Excellent. Genius answer. 0. There is no sugar in regular water. But finally, this must be 4%. Ryan, you will write all the steps and send me picture how you wrote this, okay? Which is 0.04. Who understand up to this point everything? Good, good, good. Now, this column is product of these 2 columns. So to get grams of sugar, you multiply 0.12 times 100. X times 0, which is 0. And this is 0.04 times 100 plus X. Okay, your parents have birthday. They bought 1,000 milliliter of champagne, and it's 8% of alcohol. And they wonder how much alcohol we have in this champagne. 8% is 0.08 times 1,000 milliliters. Easy. Who understand up to this point, raise your hand. Excellent. And now amount of sugar before and after. Since in plain water we don't have any sugar, must be the same. Concentration would be different, but amount exactly the same, because there is no hole in this glass. Okay, if we have here such amount of sugar, it still will be, doesn't matter, regardless how much water I put over there. Since that, you write equation. We name it a linkage equation, which contain connect few links. For instance, 0.04 times 100 plus X equals 0.12 times 100. Who understand how I get this equation? I will take different color. Okay. Who has question up to this point? Nobody? Put your hands down. Now, you can solve like it is, or better to get rid of these decimals. I would multiply both part by 100. And I will have 4 times 100 plus x equals 12 times 100. Or use distributive property. I take different color. This one, different marker. 4 times 100, 400, plus 4x equals to 1200. Minus 400 and minus 400. Cancel out. Bring down 4x equals to 800. Divide by 4 both part. I use inverse variation, inverse operation, sorry. And this will be 200. And the answer is x equals to 200 grams. So return to this model. We name it, I diluted this solution. Here we have this sugar, this tea with sugar, with very concentrated, like 12%, very dark. And I prepare this 200, you see, just plain water. Made experiment. I put over there, and this is very sweet. Yes, very sweet. I put some water here, 200, I measure this, 200. And can you see the color changes? Not so dark. Can you see this? Because for now, we have here only how many percent? 4% of sugar. If I test it, it's not so sweet at all. This is my suggestion. When in the morning you wake up, count different concentration of sugar in your tea. Okay. You see different color compared to what it was? Good. Now, who really understand this problem right now? Really? Okay, keep your hands up. What about Adelia? Daniela, Daniel? Daniela and Daniel? And Daniela? What about Yuri? 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 Raise hand.
I have a question.
Yes, go ahead.
Where did you get the 4 from to multiply the 100 and x?
This 4?
Yes.
4.0. Let me take different color. Let me take different color. What I'm doing, I multiply both part by 100. Look at this. This by 100 and right part by 100. 0.04 times 100. You move point to the right 2 steps. 1, 2, and you get 4.
Dr. Ferber,
Yes.
I have a question. Why did you do 100 plus x for T2?
Because remember, in previous situation, let's make some model. Pretend this is 100. Pretend, right? This is 100 grams. And pretend this plain water. If you add X gram of water, how much tea I will have here? It was 100. And I added X. What I have in this container, in this glass?
200?
No, it's not 200. I added 100 plus x, right? It was 100. 200 you figure out when you finish this problem. But before, for me, it was x. I did not know the answer. If you put in one container, it was 100. And you added x, you have 100 plus x. Always like this. Pretend you have this glass on the scale. If you add x grams of water, it becomes x gram heavier. Did I answer your question?
Yes, thank you.
Ask me more question.
Dr. Farber,
Yes.
I have another question. Where'd you get the 100 to multiply the 0.4 from?
This 100, this green 100?
Yes.
Well, what I did, Yuri, I just decided to get rid of these decimals. It's not necessarily to do this at all. Because for you, for students, easy to multiply whole numbers than decimals. If I don't multiply, you see what happens. Let me take this. If I don't multiply, I can solve this. Look at it. Pretend I don't multiply by 100. What I have? I will have 0.4 times 100 plus x equals 0.12 times 100. I decided not to multiply by 100. Can I do? Yes. Look at this. 0.4 times 100, it would be 4 plus 0.04x equals 12 times 100. When you move to the right, 1, 2 equals to 12. What I did, just separate with decimals. Now, what happens? Minus 4 and minus 4. Cancel out. 0.04x equals to 8. To find x, you divide both part by 0.04. Just compare this and this, what happens. How in fourth grade you divide it by decimals? To divide decimals. Get rid of decimals. I multiply this by 100, numerator and denominator, right? Like you did in fourth grade common core curriculum. And this what would be 800 divided by 4, which is 200. My suggestion, better to get rid of this decimals before. Because sometimes when you have investment problems and this is long percentage, better to operate with whole numbers. Did I answer your question, Yuri?
Yes.
Okay. Raise hand if you have another question. Daniela, ask me any question of this. I explain again.
I don't have any other questions. I was just raising my hand to show that I now fully understand the question.
Very good. Anybody else? So everybody, you have this question on the test they give you from 1993 every year. They gave you before, but I started this test in 1993. Every year they give these questions. And for me, it's like multiplication table. Create a table, my matrix, incorporate this data, create equation, find x, answer the question. And don't forget to make a circle over there. This is your target. Because sometimes another problem, they ask you to find this one. Okay, so what I did, since you don't have statewide test anymore, I prepare for you handouts, this kind of handouts, which every time compare what you're doing, you will have mixture problems. Since in chapter 12 you have only 5 items, which is not enough for practicing. If you go to gym and do 5 times, will you have strong muscles? No. Every time I give some numbers from some questions from here, and all of them must be solved by this algorithm. Okay. Who confident if I give another problem, but not right now, if I give this kind of problem at home, and you will solve this problem? Raise hand. Okay, good. Majority. If you have question, ask me before I raise it. Because we need to go to the next topic. We have a few topics for this one. Have questions? If you don't have questions, put your hands down. And you can illustrate everything using this. Put two containers and operate to see what happens. By the way, you know this joke how computer programmer go to bed? Who knows how computer programmer goes to bed? Pretend this computer programmer. Okay, he is sleeping. This is his bed. Okay. His bed. And this is pillow and this computer programmer. And next to his bed, he has a table, small table. And before to go to bed, he put two glasses on the table. Two glasses. One is full of water, and the second is empty. Why he did it? Who knows? Anybody? You know, all computers, they don't use decimal, they use binary code, 1 0 1 0, like switch on, switch off, right? And computer programmer, he thinks this way. Full glass of water is like 1 if you want to drink water at night. And empty is imitation of 0 if he does not want to drink at night. This is a joke, but show way how computer programmer thinks. 1 is full of water if he want to drink, and empty if he does not want to drink. This is a joke. Okay, maybe some of you will be a computer programmer, we will see. Well, I put it back, and now we start another topic with you. Another topic.